gigabit 00. Okay, so this one gigabit 00, and then it will go like that. Okay, so let's check the, sorry. Okay, so ping came back already. Okay, so ping came back already. Okay, so let's cancel. Then we'll do the trace, and that sorry, that one. Okay, then that one. Okay, so it says here that the gateway is still the 10.10.10.2, because only that the layer 2 path is changed. But however, only the layer 2 path is changed. However, the gateway is still 10.10.10.2, and not this one. Okay. Okay. So later on this course, we will correct this behavior for optimal path. So supposedly, if this link goes down, for now, for testing, we're just testing continuous reachability of the gateway. When one link shuts down, the spanning tree will shift the traffic here. However, the gateway is still here, so traffic will go up to core 1, but will continue to core 2 through this trunk, the ether channel trunk. But for optimal traffic flow, when this link go down, going to the primary, so what should happen is the spanning tree route will become this one, the core 1, which is supposedly the backup of the spanning tree. So this one, the spanning tree route should move here, and at the same time, the standby or the default gateway primary should also transfer here. So two things should happen when the primary link goes down. First, traffic will go to the backup link, and then the spanning tree route will transfer here. From core 2, it will move here, as well as the default gateway, HSRP standby primary. From here, it will also move here. So later in the course, we will put tracking here. So this device, we'll put tracking here on this interface, gigabit 0/2. We'll track this one such that if this one go down, we will decrease the priority of the standby for this one. So if this one default is 100, and let's say this is 130 right now. So when this one go down, we will subtract minus 40. So 130 minus 40. Then it will become 90 already. So if this is 100 and this is 90, so this one is more priority. The higher the number for spanning HSRP, the bigger it will become, the bigger chance it will become the primary active. Okay, so later in the course we will correct that, but for now we'll settle that the gateway is still active, even though the primary, suppose that used to be the primary path is disabled or shut down. Okay, so so for now, okay, we can try to put it back. Okay, before we end this long basic but long tutorial. Okay, now it's up. Sorry, this one. Now it's up. So what will happen if the traffic will go back? Will go back in this direction. We can see by the spanning tree. Okay, so the spanning tree route for VLAN 10, no change, still here. Even after we shut this down, and the HSRP standby for VLAN 10 for the default gateway. The primary is also still here. Only the change is this one. The root bridge from suite ACC1 point of view will now go to gigabit 0/1. Okay, so we will check. Spanning 3 VLAN 10. Now it's going to gigabit, going back to the previous gigabit 0/1. Okay, so we will wrap this up. Okay, we check the ping still there. The trace is still giving the IP of core 2. This did not change even after shutdown and bringing it back up. That one did not change. Okay, we'll wrap this up. So now we have the core and access layers fully operational. We've got our first VLANs trunking between the switches and HSRP providing a redundant default gateway. This gives us a solid foundation for everything that comes next. Server farms, WAN routing, DMC, wireless, voice, and all the advanced features later in the course. A short overview of the technologies we have touched in this episode. Virtual Trunking Protocol. VTP helps manage VLANs across multiple switches. A VTP server can create or delete VLANs, and those changes automatically sync to client switches in the same domain. It simplifies VLAN management, but can be risky if misconfigured, which is why many network engineers choose VTP transparent mode for safety and local control. Port channel or link aggregation. A port channel combines multiple physical switch links into one logical connection. This boosts bandwidth and provides redundancy. If one link fails, traffic keeps flowing on the others. It's useful for high traffic connection between switches, servers, or firewalls where reliability and speed are critical. Hot Standby Router Protocol. HSRP provides gateway redundancy for end devices. Multiple routers share one virtual IP, so if the active router fails, a standby router instantly takes over. This prevents downtime, keeps users online, and ensures the gateway is always available. In the next episode, we'll expand this network by adding the server farm, creating VLANs for application and database servers, and running OSPF Area 0 across our core switches. Thanks for watching. See you in episode 2.